our next presentation, we actually have one of the OpenSIPS core developers, Mr. Liviu Chircu. He's going to be talking to us about SIP push notifications with the RFC 8599 support in OpenSIPS 3.1. This is some really exciting stuff. I hope everyone's really looking forward to it.
Thank you, Alex. And you might want to write this down. My name is Chircu, right? It's not Chircu. Thank you.
I don't know who told you that, but you were misinformed.
Okay.
By the sound of it, for quite a while now.
So, hi everyone. It's going to be a tough mission for me to follow up after Alan's extremely high-level discussion and food for thought kind of presentation. But I have a couple of tricks up my sleeve that I think will spice up things in the beginning. Basically,
no worries. A cold shower, it's all the time more than welcome.
Like
coming back with the feet on the ground.
Like Alex said, I'm going to be talking about this latest RFC and both how it works and yeah, let's get into it. If a couple words about me, I'm an OpenSIPS developer. I've been doing this for a little over 8 years now, and those are a couple of handles that you can use to reach me on Twitter or IRC. And right, the exciting stuff I was going to talk about. A couple of jokes on push notifications. For example, did you know that push notification anagrams to those phrases on the right? Tuition of spinach, hot pacifist union, and a fish potion tunic. Might never know when that might be useful, right? And we're by the way, we're heading over to the peak of the presentation. The jokes. We have Moses opening up his tablet, and the push notification says, "You have 10 unread commandments." Here's one on Bob. He orders a sale on eBay, but after a few hours, he decides to cancel the order, but a push notification arrives. The sale has just shipped. And, well, that ship has sailed. And the last one is on Alice, of course, not to forget about her. And she receives a push notification from Amazon about her package of spices. The time has arrived. And from here onwards, it's all going to be, boring and a lot of SIP. We're basically going to be talking about the core problem that we are solving here, the specification that they came up with during the last couple of years, and how it all integrates with OpenSIPS 3.1. So about the problem, it basically looks like this. You are trying to reach a registered device on your network, right? We have on the right, 1 second. Okay, we have our app and it's registered. However, our invites are reaching it, but nothing seems to happen. What's the problem here? It's not the NAT, it's not the firewall, it's just the operating system of the device that has put the app into deep sleep, and nothing will wake it up no matter how many invites you send to its SIP port. Why this happens is that mobile operating system manufacturers have been trying to extend the battery life as much as possible for the last 10 years or more. But around those years, 2010 or during that mark, they started really punishing the VoIP applications, especially the ones that are using SIP, for example, because SIP is a pretty, I wouldn't say it's too noisy, but there is a constant chatter of messages being sent. So for example, the application has to stay registered, right? And periodically it has to re-register, and it has to keep on sending those UDP packets. And they simply said, okay, you are going to have to circumvent our limitation somehow because we don't want to waste that battery anymore. So what has happened? This was, again, 10 years ago. Like I was saying, this RFC doesn't solve anything new. It basically standardizes something that every VoIP provider has been solving in one way or another for 10 years now. And this is kind of the practice that has, the standard practice that has been developed. When you have a call for your app in question, you first send a push notification request to the provider, which of course reaches the phone, wakes it up, so it re-registers to the server, and voila, now you can send your invite. And for the user side, this is pretty seamless, right? Like you don't notice anything. You're just receiving a call from your buddy, Pete Za, and you take the call, close it, and you never even know that a push notification was sent. So it wakes up your device that also still has enough battery to continue. Otherwise, it would have been dead by now. So that's as far as the practice goes, and every operator more or less has included this kind of information into their SIP packets in one way or another throughout time. Maybe in contact header, maybe in some custom headers. Maybe the information was just in the database all this time, and once the call comes from the user or to a user, they would just fetch the push notification and send it. So starting 2 years ago, I guess there were some corporate interests. I don't know that much on this side, but Ericsson and Metaswitch have been pushing to get maybe their stuff standardized. So I'm not sure whether it's, kind of a race. Anyway, it's a nice thing to do, right? At least it shows that they care, because the other ones, they just solved the problem and moved on, right? They didn't bother to standardize the stuff. And mostly the work was done by Chrysler, Holmberg, and Mickey Arnold. And the discussions went on and on. Like they had, I was subscribed to the mailing list, and they had like these bursts of development where they would, Chrysler would like come up with a new version, and he would ask for feedback, and eventually it materialized, and it's now like for a good half a year now it's available. So one of the first things that it introduces is the fact that registrations on the SIP server are no longer disposable, or how should I put this? For example, let's say we have this scenario where you have a user device coming from behind the NAT. It registers to OpenSIPS, and of course it's online for the next 1 hour. But of course, there is no options being sent, and that NAT pinhole will die within the next 2 minutes. And now it's not reachable anymore. So despite the fact that the phone is registered, that registration is useless, or at least that's how we viewed it up until now. So the twist that this RFC brings is that you're not supposed to delete it, because the whole point of it is that it signifies that the device has registered within the last hour. So you can awake it at any time, no problem. Send the push notification, and the registration is all of a sudden useful again. For example, this is a good example of how our job in OpenSIPS land is to often merge between these various feature requests, because that often conflict with one another, because we have one feature request that basically says exactly the opposite of this RFC. It says, okay, the TCP connection is down, or it doesn't even have to be TCP. It may be UDP, and the NAT router still blocks the connection backwards. So it's down, so let's delete it, because my OpenSIPS is forking invites to an endpoint that is dead. So this is, yeah, you have to pick your poison, I guess, when implementing these features, because you might conflict with some other official spec. So going down to the nitty-gritty, this is the way, the official way to include the push notification information of a device into a registration packet. For example, let's zoom in on the contact header. And there are these three parameters that have been introduced: the push notification provider, the push notification parameter, and the PRID, which stands for push resource ID, which I guess is a unique way of identifying the device. And it's interesting that it's kind of a protocol within a protocol now. So they're taking this to a new level, because the purpose of the register is to register your device, right? But now they've come up with this. I mean, I'm not saying it's bad or anything, but it's just interesting to note that by omitting the PRID, you can say, I want to dispose of my sorry, I want to dispose of my push notification contact information. So you can both include it, which says, okay, this registration refresh signifies that I am also push notification available. But when you exclude it, it means it means keep my registration online, but also make sure not to contact me via push notification, because I don't want that to happen anymore. So it's quite interesting. And they've also done a similar thing with the provider parameter. And by omitting it, you are signifying that you are just querying for push notification information, not registering anything. And my voice is kind of going down. Yeah.
Do you have COVID?
Where's the whiskey?
Yeah, I have an allergy. Right.
Hopefully not the whiskey.
Yeah, I'm better now. And there's also an additional parameter here that might be useful. I'll get to it in 1 second. Now, what does the server reply? Of course, it returns your original contact, that whole bloody mess. But it also has to say, okay, I've got push notification awareness as well. I've got support for the RFC. And here is where I found out that there is an RFC that allows you to do this, of course. It's 6809, released in 2012. And that defines the feature caps header, which does nothing more than it's another directory of possible capabilities that a SIP server may be equipped to handle. And the push notification RFC 8599 simply extends this registry with yet a few more parameters. For example, the first one is the PNS, the push notification service. And in this example, the server has support for the Firebase cloud messaging platform, FCM, and also there's this PNS registration. I'm going to talk about it in 1 second. Here's a listing of all the capabilities which are introduced by the RFC. On the user agent side, we have just the registration one. And on the server side, we have this bunch. We talked about the first ones. I'm still left to describe the registration. And the PER, that is the third part of the presentation. And this Vapid thing, basically, this is for the open version of the push notifications. If you are familiar with web push, that is where the Vapid will come into play. So if your SIP server will have to send generic, or how should I say, open, right? Open standards-based push notifications, and not walled garden push notifications like Apple push notification service or or the Firebase ones, then you're going to be using the voluntary app identification ID, which will simply say that your SIP proxy is authorized or is a valid originator of push notification requests. Because for the other ones, the Apple and Firebase, the simple fact that you have the token makes you authorized. You don't need a VAP ID anymore. So that's the point of the VAP ID. And that's the last time we're going to be talking about in this presentation. And a registration refresh. What's about this? This is kind of the second important concept of the RFC, is that registrations are not, like I said, they are not being generated constantly by the device because it is asleep. Whereas now the proxy has the responsibility of re-registering each device, if that makes sense. So with regards to that, the recommended duration is 120 seconds before they expire. The proxy will initiate the same thing, send a push notification request. So a push notification gets sent, so the phone re-registers and refreshes its registration. Boom. Some phones may be smarter. And in this, for example, they are capable of re-registering by themselves. They have some sort of timer or wake-up mechanism or whatnot. And that is where the push notification service registration thingy comes in, where the server indicates its recommended time when the device should register. In our case, we went with the 130 seconds. So it goes like this. Let me show you. So for example, if we go back on the 200 OK message to the register, OpenSIPS is indicating to the phone that around the 130 second mark before the expiry happens, they should re-register. And it's going to give the device 10 seconds. If it doesn't register, the registration timer will kick in anyway. And the proxy will send a push request and it will register by force. So it's kind of a useful thing to have. Maybe it will save on some push notifications on some scenarios. So it's nice that they made this, this capability. So that's all about this, the refreshing your registrations and keeping them, keeping your phones online. The next important thing is how do we handle initial requests for dialogue? And the flow is exactly the same. Nothing changed. Like I said, the RFC merely standardizes a practice. It doesn't invent the wheel. We have an invite for our app. We send a push. It re-registers. Now it's accessible. And there are a couple of things to be said about the contact header here. For example, this is if we invite Alice at example, and her contact marked in red because it's corresponding to the register message. So the registers are red and invites are blue. And it's this big thingy. If we put things together, the forwarded invite would look like this, right? Not really. They've mentioned this in the spec, and they said the push notification parameters must be trimmed away. It's very important that the push notification proxy takes care of this part. So actually, the whole flow would look like this. They invite, we do our push notification and re-registration, and then we clean up the request URI from any push notification parameters. Okay. I notice Dan has a question. So
I was just about to tell you.
Yeah, I guess I should take care of it now. Let me know if you spotted any other questions.
No, take care of that question.
So Dan says, if you're sending the push on an invite, why do you need to why do you need to do register contact refreshing? That is a very good question. And again, it's relating to that concept of, is the device online or does it want to be awoken? Because maybe you closed your app, right? Maybe you closed your Blink. Again, I'm not a VoIP app developer, so maybe I'm talking, I'm not that accurate. But conceptually, if the app is dead, it's not meant to be woken up. Or maybe for some reason it purposefully not register, right? It did not refresh its registration. So the RFC clearly says, the 8599, do not send a push notification if you don't have a registration for the phone. Because if the phone would have wanted that push notification, or if it was push notification available, it would have accepted the registration refresh notification. So it would have been online right now, or at least it would have had a binding that is still due to expire. Let me know if that answered the question. So it all boils down to this slide, the no cleanup slide. Keep these bindings alive, even though they do not immediately point to the phone. It just signifies that the phone is awaiting a push. Okay, so I'll move forward and I'll asynchronously pick up your answer. Right, so this brings us to the big dragon of this specification, the PER mechanism, which is a problem that like all of these problems, they did not foresee immediately. And Chrysler realized this at some point during developing the RFC, and he said he noticed this problem. So we get the invite. So we're in the context of mid-dialogue requests. We're already established a dialogue between, or better said, we are establishing in the upper part of the slide, and the problem comes in the second part of the slide with the requests which are originated during a dialogue. So we get the invite from Bob, inviting Alice, with his contact, which mustn't necessarily point to an active registration of his. It can be any contact, really. So the proxy cannot pinpoint Bob's push notification coordinates. This is the main problem. I don't know how to reach Bob. Of course, I can establish the call. That's not a problem, as you will see right now. But keep this in mind. Of course, it looks up Alice at example. It pulls her registration binding. It's routable, blah, blah, blah. We route to Alice. Even if we have to send a push, we do it, but we can route to her. That's important. And we can store those coordinates in memory. If you are familiar with OpenSIPS dialog, you can just put them in the dialog. They will be available. If you have any mid-dialog request, boom, you will just send a push notification. But what if the mid-dialog is sent by Alice? What if Alice puts Bob on hold? This is the problem. Because now we would like to send a push notification to Bob to wake up his device. Maybe they have been talking for like 15 minutes and the SIP ports have been closed at firewall level. They are not accessible right now, despite the RTPs flowing. So the problem is that despite during this dialogue, Bob can still put Alice on hold thanks to our coordinates which we've stored in the dialogue. This is asymmetrical for Alice. Okay, so how did the guys go to fix this problem? They came up with this proxy unique registration reference concept. As you can see in the slide, the text is red because this feature is tied to a registration and its reply, the 200 OK. And the proxy now also has this tag for each registration. This is not like rocket science. If you've played with OpenSIPS, you will have realized that we assign a unique ID to each registration anyway. It's the contact ID, remember? It's that big old number, 64 bits of information. Actually, between you and me, this ID here is just a contact ID that's written in hex. So boom, we had this anyway, so we just reused it and changed up, flipped the bits a bit just to make it more obfuscated. And there you go. We have our proxy unique registration reference, which sounds amazingly cool, which is handed out by the proxy when you register, right? So you learn your, I like to call it PER. You learn your PER, right? What now? So right now, a phone, Alex, you have anything to add?
I just thought we all needed a little bit more explanation on PER.
On PER? Okay.
Why you
Sure, go
specifically
ahead.
no, just a little more explanation on the PER.
Oh, why I like PER?
Exactly.
I don't know. It kind of reminds me of an engine, right? It purrs like a kitten or something. I kind of think of cars when I say it. Yeah.
That
Purr.
completes the picture. Thank you.
Right. So I'm glad that I cleared any misunderstandings. Right. So it's simple. You register, and not only does the proxy tell you that you're registered, it also gives you this ID that you can remember for your registration. Now, what you can do with it, once you've established the dialogue between Bob and Alice, or when you establish the dialogue, so when you call, each phone has the option of including its PER into the contact or not. I guess that there was also a point to make. Let me pause this idea for 1 second and go back to the original slide here, and with the problem. So an obvious question here could be, why didn't they simply put their push notification information in the contact during an invite, so that the other side sees, or at least the proxy knows where to send the push notifications to? Well, it turns out that this would basically leak information, or I'm not even sure, because the proxy could have stripped away this contact when routing out the invite, so it would have worked. But yeah, I don't have much in my head. It would have worked. Maybe I just cannot come up with a decent explanation for why the devices aren't supposed to include their push notification even in the invite, with the obligation of the proxy to strip out on both ways, right? Because even the 200 OK will contain the coords of the other one, and the proxy strips them out. But maybe, now it makes sense. Well, this is against the RFC. Proxies are not supposed to touch the contact. Okay, that's why they didn't do this stuff, right? So it's kind of a conflict here, right? You want to advertise that information, but at the same time, for the proxy, but at the same time, since the proxy is not supposed to touch the contact, you don't want to leak your push notification information to the B side. And similarly, for the symmetrical flow, the 200 OK, which contains Alice's push notification, is not supposed to be leaked to Bob's side. Right. So this is why this is the first time that the phones decide to advertise anything about their push information, is when they include this PER during an invite. their own PER, of course. If the phone doesn't include it, which is perfectly legal from RFC point of view, it simply means during a mid-invite request, you cannot send a push notification to that phone. I'm not sure. It could be problematic, but they can do that. So I'm not sure how you're supposed to reach that phone, but it's in the specs, so it might fit in for some scenario. It might be useful to not include your PER. That's thus making yourself push notification free, let's say. Okay, so Bob puts his PER, Alice puts her PER in the 200 OK, and right now we have full symmetry. Of course, I'm not sure if I recall whether the proxy is no, the proxy is not meant to strip anything. That was the whole point. Of course, each side will learn about each other's PER, but who cares? It's supposed to be an opaque identifier that shouldn't leak any information. So that is the whole point of it. You mask your push notification information, right, in this ID that nobody can extract any information from, so you are reachable during the dialogue. Cool. And as I was saying, this is how a mid-dialogue request to a PER-enabled contact looks like from each side. And the proxy will, I'm not sure. Do we strip this one out or not? That is the question. I guess, again, you can take your pick. But at least you have connectivity. At least you can wake up the devices during, let's say, the call hold that comes up 10 minutes into the conversation, where by this time the NAT has been long time closed and the phones are unreachable via SIP unless you wake them up with a push notification. So that was kind of it. How did it all seem? Was it too complex? We at least we did RFC. Do you have any questions by this point? I guess not. All is clear.
There is some questions on the channel.
Mm-hmm.
If you look at it.
Okay. Let me switch a bit.
There's a question from Grant. He says, maybe I missed it, but how does a phone app notify the proxy it's available for receiving push notification? Which
Perfect.
triggers the push, yeah.
Perfect. This is the very first slide. It's when the app registers. All it has to do is to include its push notification information in the contact. So as you can see, you put the semicolon and then you list the provider, parameter, and push resource ID of your phone. And that is all. You don't have to do this reg thing. You can just skip it. So these three parameters matter, maybe even two of them. Maybe you can skip the param. It depends on the service. And subsequently, as I was saying, the cool thing is that you can re-register via SIP, but you can omit the PRID, so it means that you're not push available. Again, I'm not being an app developer, I cannot foresee how useful or what type of UI interaction this is going to translate into, but it looks pretty cool.
I have a question, guys.
Sure.
Liviu, what is the easiest way for someone to play around with OpenSIPS and push notifications to make it work?
Perfect. Vasilios, this will be answered in the final section, where we will talk about how we implemented this into OpenSIPS. And let's get into it.
Okay.
Basically, there are two big ways of integrating this with OpenSIPS. 3.1. This is the last year release that we introduced this support in. I mean, the current year release. First, you can just replace your existing registrar, or if it's OpenSIPS already, you can upgrade or whatever. But this may be a bit intrusive, or it's not maybe, it's obviously intrusive, because maybe you're going to have to take it down, and there may be, anyway, in some cases this might be completely doable. So that is the first case when you might go for this architecture. Or maybe you're doing a proof of concept like Vasilios wants to, or just a test server. Right, this is the ideal. Just use the registrar module. But we've also imagined the scenario or the problem where it's not that easy to change your registrar. Maybe it's some kind of vendor locked in device, or maybe it takes up a lot of effort to change. Things are working, you don't want to break things or invest a lot of effort or human effort into rewriting that whole thing. And not to mention downtime, or no, I guess downtime is not a problem because you can do it on the backside. So we've added a way for you to just make a lightweight proxy, push notification proxy registrar. A quick question here from Gary on Slack. Has this been tested with Android or Google? With which client? And to answer that, there are more sides to the story. For example, I've just tested the specification with my own stuff using SIP-P. However, the Android pushes are simply sent using a post, an HTTP post. So it's a bit decoupled, but we are working. So to fully answer your question, we are working on integrating this with both Android and Apple, and I will let you know once things go ahead with that project. But for the moment, I've only tested this using my own tooling, and the push requests themselves are done using the REST client module, which I'm going to talk about in a second. So going back to this, we have this option of building the lightweight registrar. Of course, you're going to be using the mid registrar, not the registrar. And these are kind of the scenarios that I mentioned where it might come in handy. So the lightweight solution, the microservice, instead of monolithic. So with regards to the code, the changes span across several modules, the registrar and mid registrar, of course, but also the user location module, which has received some tuning. The cool thing is that it's all backwards compatible with what we had before. It supports plugging in both the user agents which advertise these push P and S parameters, or the ones which are simply oblivious to everything that's going on. And this is kind of a developer cool thing. The code is common, right? So we haven't copy pasted the code nor the documentation, and it's in its separate folders or in a common folder. I guess it would be interesting to show you the module parameters and talk a bit about them. And for this, I'm going to head over. Let me see if I can share this tab. And I'm going to head over to opensips.org and go click by click. Let me see if I know it. We go to documentation on the manual for, let's say 3.1. And we are going to pick modules. And let's go with registrar. And if you scroll down a bit, maybe, is this full screen, or is it okay for the font? Let me make it bigger, maybe.
Yeah, it's fine. It's okay.
Oh, it was fine? Okay. If we scroll down, you will see these new parameters prefixed with PN. So everything is push notification. And it's both in registrar and mid registrar. It's the same parameters. And to enable the whole thing, you just have to set enable to true. you will, oh, my scroll is broken. And of course, you will have to define a list of providers. Depends on which phones you want to support. Of course, for each provider, you will have to implement the push notification route. And how to match parameters, like we talked about, the default value are the 3 parameters. Not much to look at here. And the registration intervals, the 130 seconds. This is the phone which registers by itself, and the trigger interval, which is the periodic refreshes triggered by the proxy. Sorry for that scroll. This is kind of an experimental parameter that I added. Maybe sometimes after a successful push, maybe the phone is online for a few seconds. We have to play with this and see if it's useful or not. By default, it's disabled, but maybe you can extend it and say, for 5 seconds, don't generate any further notifications. I trust it to be online. Okay. This is a refresh timeout. Basically, it means how long to wait for a push notification to happen. Because if you think about it, and Chrysler really mentioned this in the RFC, the RFC adds, or not the RFC, the whole practice has been constantly adding latency to the calls, right? Because you have an invite that is pending, and the caller is basically waiting for their call to ring. So this timeout says, okay, how much longer will we have to wait for the push notification? Because I have to say something back. Maybe I'm going to give them a 480 or something. This is the timeout. And of course, to enable the mid-dialog per mechanism, you have to set this to true. So as you can see, it's very mod param heavy. There's not much to do in the script. It's we really striven for. Okay, I'm going back to the slides. So we really went for that to make it as easy to use as possible. So these are the module parameters. Of course, I've missed out on the user location one, because if you use this RFC, you will have to enable that timer that periodically generates the push notifications. So just set that to true and you're good to go. So I guess we're going to look at the event. So this happens, you're going to be called with this event. This is a new event we introduced in the user location. We called it contact refresh. So it's kind of a generic way of saying this contact needs a refresh. You can refresh it in however way you imagine. In our case, we know that you're only going to be able to do it via push notification, but who knows, maybe in the future, there will be some other methods to wake them up. So in this event route, we simply do our thing. I'm not going to cover the specifics of the push notification on each service, Google, Apple. It's up to you to figure out the documentation and just use REST client and send that HTTP post. And as far as scripting goes, not just module configuration, we've made this small extension to the lookup function. Of course, the lookup is in Registrar, and if you're using mid-registrar, it's a mid-registrar lookup, so it's the same extension. And while before the lookup was kind of binary, it just said, I found some contacts or I didn't. Now it's saying that, right? The green is I found some contacts or I didn't on the default, and the temporarily unavailable reply. But there's also case 2, which means I found some contacts, but we still have to wait on them. You can't do much. So just skip your relay. We set this AVP to true, so we don't relay anything, and just quit the script. What happens under the curtains, if you're familiar with the event rounding module, is that a temporary subscription is created. This is a quite complex, I mean, not that complex mechanism, but it's interesting nevertheless. A subscription to the registration event or to a future registration event, such that if that happens, the transaction will fork out an invite to that device. It's a mechanism that Bogdan presented or introduced, I guess, in both of them, both introduced and presented in OpenSIPS 2.3. Maybe he can let me know if maybe it was 2.2. I'm not sure. Right. So the good thing is it all happens behind the curtains. You just set that, what was it? The refresh timeout, and you just break the script. The invite reply will be generated if the timeout is reached, or if not, the forking will happen magically almost. So we move on to what happens with the per processing. And basically we extend, so we took care, what we talked about here was the initial invite, and that's all you have to do, just extend the lookup a bit. And for mid-dialog requests, you add this code, or maybe, how should I say it? We have to process it asynchronously because we have to break the script since we cannot route anything. Let's take an example. We receive a re-invite for a call on hold. I cannot route that invite out until I receive the register. That is the problem. So that is why we use the async. We are kind of forced to do it here. Here, on the initial invite, we didn't have to use the async keyword, right? Like async lookup or something like that, because because the whole mechanism is hidden within the TM internals, and we could get away with this clean syntax. But during mid-dialog requests, this is kind of the best we could do, and the whole processing moves to the resume sequential route. That is all. We just process that per token, and of course, if there is no per token, because there will be re-invites without that, the script continues immediately. There will be no blocking or anything. So it's a little bit of an extension to the mid-dialog request routing. So as to close off the presentation, I will be sharing with you a discussion or a quick review. You are presenting. I guess I need to stop presenting if I need to share a window, right? Temporarily, at least. Yep. Present a window. Terminal. Okay, so you should be seeing this terminal. Can you see this, guys?
Can you please increase?
Yeah, increase the font.
Increase the font, absolutely. How is it now? Good?
Good.
Much better.
Okay, so we are going to be looking at a diff between the standard OpenSIPS CFG and a CFG with kind of minimal push notification support enabled. Yeah, without any unneeded parameters, right? We're just using the default values, just a minimum viable product. So as you can see, we have to enable the refresh loop within the user location. So the proxy is taking care of the refreshes. So soon enough, the proxy will be doing the calls for the phones as well. I'm not sure. We are moving everything into the proxy. And the registrar, we enable the PN parameters, both the support and the mid-dialog request support. And we have support for Firebase and Apple. Awesome. As far as load modules go, we load the event routing. This is, I guess, and this is also the last time we will be talking about it here, but it's a very important piece of this whole puzzle. right? And the event route, so we can catch the event, and REST client to do the HTTP posts. But again, I'm not going to be doing them here. It's just as food for thought. I'm going to be starting with the initial dialog part. As we saw in the slides, we delete the lookup part and we add handling for the case 2, the case where we have to wait a bit. So we found some contacts, but it sucks. They're not immediately reachable. There is no T relay. And here we can see that we skip it for those contacts. We just exit the script, and the invite will be forked transparently when the register arrives. That is using the event routing module. And in the last part, this is the event route where we will send the push notification. I've marked it here I've just put an exit. You receive the inputs, provider, push resource ID, parameter, maybe even call ID if you want to do an Xlog or something, and you're off to go. Just have to read the docs from Google or Apple and send your notification. And this is and for the sequential requests, if we go up, we maybe one idea is to show the config, because this is a bit messy. Let's view it like this, maybe. Right. So if it has a 2 tag, it means it's a mid-dialog requests. We get rid of the ACKs and make sure it routes properly. And once it does, we cannot do much more. We just have to do the handling for the per parameter and then put the request on hold until the push notification arrives, and we can resume our sequential request processing. And basically just put the code here, right? Accounting and relay. And that's about it. Those are all the changes. Let me go back to the slides. Where is it? Google Meet. I guess. Okay. 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 So these are some links that might be useful to you. And right, that was it. This is a seamless integration in 3.1 that is fully available to you to test and play with. Thank you. And if you have any questions, please fire them away.
Thank you. Thank you, Liviu. While we're waiting for questions, I just wanted to check with you. We wanted to do OpenSIPS next week. So maybe in terms of this particular RFC, we can have maybe 10-15 minutes tomorrow during my slot to plan it a little bit further.
Sure.
And then if anyone interested in actual configuration and more details next week, we'll have probably a few hours playing with it.
Yeah, that would be great. Like I said, we are testing. We have a client that we're building this stuff with, but it's going to take some time until they build their UAC as well and fit the pieces together.
But Maxim, do we have any kind of a client to test with? Out of curiosity.
No, but we can build one. I mean, we have a Python library which can register and can send and receive calls. So I guess it won't be too...
Come on, guys.
I think Lincoln
has the CP. Maxim has Python. We have mobile phones. We need application here to test.
Exactly.
I know that like Linphone have their own way of doing it, and they are already doing it for like the last 3 years over the registration. And the question is if there is like any trying to get them to change their protocol to work by the RFC, or there is any client right now out there that implements it?
That is what I was asking in first place, Liviu, before.
Yes, these are excellent questions, guys, because from what I've heard, no, not really. This is just a spec that was pushed, like I was saying, by Chrysler and Arnold, and I'm not sure, last year, right? So I'm not sure how many people managed to get up to speed with it. So I would expect that maybe LeanPhone will be using their push notification solution for like 5 more years.
I see here Vlad Payu, it's throwing in the bomb, saying that LeanPhone for iPhone should have support for this.
Wow.
Okay, he said that it's advertised on their wiki, but okay, not tested yet officially. So
awesome.
We will help them. We will take it on our responsibility to be annoying to them, let them know to make sure that they will need to apply the RFC. We will beg them, send them nice stuff, whatever we need.
Another GoFundMe campaign in the works. Well, Dan Jenkins, you've been really kind of in the fold of like all the conversations in here.
Yeah.
I think that you're probably the best suited for like taking on the questions from this point.
I don't know about that. So I have the benefit of building WebRTC apps with React Native with web tech, and I'm not really tied down to SIP only solutions. So yeah, I've got quite a bit of freedom, but I completely understand why this RFC exists in the first place. The first time that I saw OpenSIPS talking about it, I was like, oh, this is really cool. This should hopefully help standardize everything.
Yeah.
But unfortunately, I hadn't really read too much about it because I wanted to wait for this. And unfortunately, after that, I was like, well, I can see there's going to be loads of issues. So we were talking about PushKit and CallKit integration in the chat. So if you don't know, Apple on iOS 13 changed the rules. So if you want to send a what we call a VoIP push notification, which allows you to have a bigger payload and it's quicker across their network, because phone calls should take priority. So they're special. They're called PushKit notifications. But if you want to send a PushKit notification, you have to start up a call screen immediately. So there's no receiving a notification and then just registering and then waiting for the invite to come in. You have to kind of pretend that you've actually got the invite already. And I can't see how this gives us that flexibility to be able to handle those situations kind of in this nice way. So a question to you is, could it handle these situations where we need to essentially send a load of information about the invite in this kind of registration push that gets sent down, but then also handle the fact that a cancel might happen in that short space of time between that fake invite as such being sent, but a hard phone or the other person on the other end has already cancelled. And so we've got this scenario where the iOS device is still ringing because it doesn't actually have an invite yet, right? But this is the annoyance with building with push notifications in mind. So yeah, I'm throwing that back at you. What do you think?
Right.
He looks like a deer in headlights, man.
Yeah, I'm not sure if I understood the call flow exactly, but what I'm going to say is that we are testing with the Apple push notification service. So we're building the client. So we'll have to see what kind of issues we run into, and I think I'll get back to you once we hit those. Maybe the guys have got it covered, but they seem to be pretty confident. Well, but I guess, yeah, well, we might be overlooking something. I'm not sure. Yeah. You said about the app not being able to route out an invite and wait for the reply asynchronously, or what is, I'm not sure exactly what is the problem, but so I guess
I guess a clarification question from you then is on an invite, is the push notification that gets sent on an invite something that causes a registration to happen, or is it actually an invite push?
No, it is a push notification that causes a registration to happen.
Right.
Yeah.
So this is the inherent issue with PushKit and CallKit. So because you have to show a call screen using, if you want to integrate with CallKit, i.e. iOS's call, their built-in stuff. If you want to integrate into that, which you do, then what am I trying to say? If you want to integrate into that, then you have to show that screen when you receive your push. But your push is actually only to cause a register. So inherently, you kind of have to send down some call information on that registration push to go, oh, this is the caller's name, this is the caller's number.
It's ringing.
And it's ringing, but it's not really ringing yet. So we get into this mess where call state isn't actually truthful, right?
I see the problem now. The problem is on the receiver side. The phone has to be responsive because we're building these nice user interfaces that I don't know, don't make us wait or whatever. So it signifies the wrong thing. It's ringing, but it's just sent a register. But it will take a while until the invite arrives, and you know what? It might not even arrive at all.
It might not even arrive
because the call might be canceled. Right, so that's the problem.
Call might be canceled, so it might not even arrive. At which point we need a cancel push as well. I'm getting really into detail. Also, depending on where you are in the world, you have varying response times to pushes. So in Europe and the US, we are very fortunate with being able to receive a push notification from Apple or Google within like a second. We're extremely fortunate. A lot of my clients are elsewhere in the world, and we actually measure how long it takes, and it's a long time. So ultimately, you could be waiting 10, 15 seconds just for the push, for the register to happen, for everything else to happen, just to be able to go, oh, I've actually got that invite. At which point the other person might have already hung up.
Absolutely.
So it's a mess.
In the RFC, they just say that from their experience, the push notification on average takes 2 seconds. We'll see if that's the case. Right.
It's a lie. It's a complete lie. Sorry.
Wow. Okay. So I think we should wrap up because.
All right, gentlemen, to your corners. To your corners.
Right.
We have tons of more questions on this, and as you can see, our time is up at this point. So Liviu, he's pretty available. He's on several channels. You could take up those questions further with him.